Hi folks, I want to share with you just a little video on how to work the simulation for our virtual earthquake lab. We are going to be using that triangulation method from the Edpuzzle video that you watched yesterday. The computer's actually going to do it for us, but we need to figure out what's the difference in time between the S and the P wave, and then figure out the distance from that location using the chart, and then the computer does the rest for us. We're also going to figure out how big the earthquake was in magnitude for the Richter scale, which we just talked about. So let's first off start by clicking on our link and taking us to the earthquake lab. So here it describes a little bit about what an earthquake is. We're going to look more closely at the seismograms. It can give us information about when the P wave arrives, when the S wave arrives, how much time is in between, and also how large the earthquake is. So we have time on our x-axis and millimeters of how much the ground shook on the y-axis. You can scroll down all the way to the bottom, and we're going to have 4 different locations. I'm actually going to use the Japan region for our model example today, and then you're going to actually calculate the San Francisco area, Southern California, and Mexico. So I'll do one of them, and you do the other 3. So submit choice, and let's get to it. So here's a little map of the area of where all the cities are. What we need to do now is take a look at some data from each city from the seismogram, and then we're going to calculate the time intervals. So here we have our first graph from Busan, that seismic location. You may notice that my screen is going to be a little big. That's because I went up here and I zoomed into 150%. It's going to help with reading the graph. You may want to do a little more or a little less depending on your eyesight. So here we have time 0. That's when the P wave started to arrive. And we travel over here, the P wave fizzles out, and then the S wave starts. And we need to figure out the time in between. And so each block going left and right is going to be 20 seconds. 2 seconds. Each block going left and right is 2 seconds. So this is 50, 52, 54, 56. So P wave starts at time 0. S wave comes at 56. So our interval is 56 seconds. If we go to Tokyo now, so Tokyo started at time 0. The P wave fizzles out, and then the S wave hits, and that looks to be 42 and 44 seconds. So type in 44. And finally, for Akita, that earthquake seemed to be pretty far away. We have a pretty small earthquake felt there. Time 0, P wave fizzles out, and the S wave seems to be between 70 and 71, or 72, so that's like 71 seconds. So 71 seconds. Now let's convert that time interval into distance. Now, we're used to seeing a graph that looks like this with the S and the P wave, but what we're going to use is something fancy, is just an SP wave line, all right? And all we need to do is go up on our y-axis for our time difference, go over the line, and go down to our distance in kilometers. Now, each block going up is going to be 1 second, and each block going left and right will be 20 kilometers. So let's do this first one for Busan. We calculated that it was 56 seconds between the S and the P waves. So we'll go up to 55, then one more block is 56 seconds. And so that looks like it's at about 2 blocks over. So that's going to be 540 kilometers. So 540 kilometers. Let's go to Tokyo. That's 44 seconds. So we'll go up to 44. And that looks like it's halfway in between 420 and 440, so maybe 430 kilometers. And finally, go all the way up to 71 seconds. And again, it looks like it's halfway in between there. So halfway in between 680 and 700 is 690. We'll find the epicenter. So this does tell us exactly, hey, we got it correct. Now, if your numbers are way, way off, it will make you do it again. If you're kind of close, you can continue on with the simulation. But I've done this a couple times, so I know what the correct data should be, so I plug that in. Now let's move on. We know where the earthquake started from. Let's figure out the magnitude for the Richter scale, which is something we quickly talked about before the lab. So compute the Richter magnitude. So magnitude explained. So this is something that we just talked about. You can scroll down to the bottom, but just remember this graph from the middle line up to the top of the highest peak, that'll tell you how much the ground shook, and that'll give you the amplitude or the size that the earthquake shook the ground. So let's keep on moving. So here we go. This again is going to tell us wherever the lines cross on this magnitude. Each little tick mark goes by 0.1 on the Richter scale. And when we get those all lined up, you're going to see we can calculate the magnitude of the earthquake. So here we go. Let's look at these seismograms again. And so going up, each little block goes by 10 millimeters. So 50, 60, 70, 80, 90, and then 100. And so let's take a look at this S wave, because remember, S waves shake the ground up and down. And so we're going to look at the highest or strongest part of the S wave. That looks like it's right here. If we travel that across in a straight line, that's 10 below 100. So that'll be 90 millimeters that the ground shook. If we go to the Tokyo seismogram, it looks like it shook a little bit more, and this is 150, go up another block, 160, go up another block, and that's 170. And for the last location, the Akita location, again, this is our S wave. It looks like we go up 10, 20, and that's 30 right there. So 30 centimeters, the ground shook. And so finally, we're going to submit our information. And here's where we're going to see where all three of those lines cross. We're going to try to pinpoint the magnitude of the earthquake. And so it looks like that this is 7, therefore this is 6, 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8. I'm going to estimate that the magnitude of the earthquake was 6.8. Well, I'm going to go back more like 6.7. 6.7. So confirm my magnitude. Let's check out our data. So congratulations, you've done a great job. What you're going to do now, this is a very important step, is you're going to click Get Certificate. And this will tell you all of your data. So all of this information here, what your calculations were and what the actual calculations were. So I was pretty spot on with the time difference. I was a little bit off for my distance, and my amplitude was a little bit off, but I was pretty close with my magnitude. All of this information right here, if you go back to your lab, is where you're going to fill in all of this right here. So type in the name of the city, put your information, the actual for the S&P, the distance to the earthquake, the amplitude, how much the ground shook, and then calculate the Richter scale. I should make a change right here. I should merge those so it looks more like the ones that we have inside of our lab. All right, so do that. Again, I'm going to fill this data in for Japan region, and then you're going to be able to do San Francisco, Mexico, and Southern California. So you're going to do those three for the lab. Hopefully that helps. If you have questions, always ask during the class. I'll try to clarify anything for our lab. Good luck.